show you how to go. To the right, to the right, to the right, to the right, to the left, to the left, to the left, to the left. High kick, high kick, high kick, high kick. Now walk it by yourself. Now walk it by yourself.
All right, all right, all right. We are talking about the end of this chapter review, which is the basically normal distribution. And as you can see from this cartoon that's on in your book on page 106, we're talking about left skewed, right skewed, which is the right answer, etc. So during this video, we're going to be talking about cumulative relative frequency graphs, ogives, really quickly. How to standardize. Remember, when you see the word standardized value, you're looking at the idea of Z-score. Okay. The effects of adding or subtracting a constant, effects of multiplying or dividing. Make sure you've written down this term. This term is referring to transforming the data. I didn't say we were going to mention percentile, but remember, a percentile is the same as a proportion, which is the same as a percent. Just a second, some dweebs are looking through the thing. I'm sorry, that was a long pause. I'm not sure where I was, so I'm hoping I'm picking up from where I was before. A percentile, remember, is a separator that separates separates you from people that did better than you, than people that did not as well as you. And how we find a percentile is literally find the probability, and after we do that, then we just change the terminology to the word percentile. Remember, probability is the area under the curve, but a percentile is literally a score. Next, as I look at this right here, next terms we're going to refer to as a density curve. So please remember, a density curve is not just a curve. It could be a normal distribution. It could be a uniform distribution. So it could be the shape of a bell curve, or it could be the shape of a rectangle, or a square for that matter. Normal distribution, we've done many of that. Normal curve is the bell curve. The 68, 95, 99.7 is 3 standard deviations within the mean, 1, 2, and 3 respectively. The standard normal distribution. For the standard normal distribution, that's when you have the Z-score of, I'm sorry, I'm about to say the wrong thing. When you have the mean of 0 and the standard deviation of 1. So that's what the standard normal is. So whenever they say that, you automatically know mean is 0, standard deviation is 1. Here, the standard normal table is nothing but the Z-score table. And I never refer to it as that, but that's what it is. Normal probability plot, remember, that's when you look at that plot, and if it's linear, then you know that the data is approximately normal. So let me just jump into some examples and some other things. Okay, now go ahead and read this question, and we're going to do it together. So pause. Okay, so to answer one of the questions that you guys requested, is the 68, 95, 99.7 rule, being able to do the calculations. So if you notice here, they gave us the mean of 83 and the standard deviation of 5. Remember, the middle 68%, which is about here, okay, that is going to be 1 standard deviation within the mean, so plus or minus. So it's 83 plus or minus 1 times the 5. Remember, the mean was given to you to be 83, and the standard deviation was given to be 5. So you're just taking it and plugging it in. For 2 standard deviations, which is the middle 95%, same idea. It looks like it's here about. There you go. And you just go ahead and do the math. So 83 plus or minus 2 times 2 times 5. So it looks like it's 73 to 93, and you can see it here. And then 3 standard deviations away is 83 plus or minus 15. And then you can do the math, but the score is going to be about here. Okay, so that answers one of you guys' questions. Next question was here. Another question I was asked was how do I know to use normal CDF or inverse norm? So first of all, I need you guys to write down this question, and then let's do it in our calculator. And I'll also show you the expectation on how you should write it down for full credit on the AP test. Okay, so here's your formula, and remember, you're using normal CDF because they're asking you to, where'd the question go, what percent? If it says what percent, what proportion, that's when we use normal CDF. So you just take it and plug it in, and eventually your answer is going to be, looks like 81.5%. Okay, and as you can see here, your presentation, you've covered everything here. You cannot have this alone. Remember, this is calculator talk if you have the calculator ease alone. You don't have to have that, but you must have this. And yes, give me a legitimate bell curve shade underneath. Okay, as we look at number 3, go ahead and read that. And as you after you've read it here, remember we're looking at greater than, earned to A, so that's greater than 90. Okay, now as I look at this, you might like this presentation a little better. You find the Z-score alone, and then you put the probability of the Z that you found, and then again we are using normal CDF. We are not doing the table, and it takes you directly to this answer. And don't forget, leave your final answer in a statement. I just noticed number 2, that I didn't answer it the way they wanted me to, that I didn't use the 68, 95, 99.7. So I'm going to go back and look at number 2. Because I didn't follow the directions. Now let's follow the directions in number 2. They asked me for the 60 to use the 68, 95, 99.7 rule. Please remember, from here to here is 95. I'm sorry, from 93 to this point right here. From these 2 points where my fingers started in, that is 95%. So that means this portion right here is 47.5. Okay, as I go from here to here, this is 68%. That means that this is 34%. And then you can just add the 2 together. And as you can see right here, here is the math. And the reality is, the other answer I gave you, if it's off a little by using the calculator, so be it. It's the different methods. But now that I finally followed the directions, there is the work and there is the answer to support that question. So no normal CDF if we had truly answered the question like we should have. Now I'm going to skip number 4 because number 4 was me doing number 2 incorrectly, unfortunately. So right here, as I see, I want the 20th percentile. Okay, so go ahead and answer that. Okay, now, as we look at their answer, we can do this in 2 ways. First of all, we're going to put this in the calculator, inverse norm. So one of your questions was, when do I use inverse norm versus normal CDF? Well, remember, inverse norm is you have the percent, you're going in the inverse of finding the normal proportion because you've got it. So I've got the percent here, which is the 20th percentile, and that means I need to, if I have a percent, why should I look for a percent? Because that's what normal CDF does. Inverse norm is I don't have the value, I've got the percent, so I've got to work backwards on the inverse. So you can plug that in your calculator. Okay, or I want you to notice something. Here they say the 20th percentile corresponds to. So when you come up with that magical value right there, you've got to do, and remember I showed you that on the board also, you've got to connect that 20th percentile to that Z-score. And remember I told you, if you don't know how to do it with symbols, use your words. That's what they did. They used their words. So you have this, and then you just solve for x. And eventually, you're going to get to this value right here. Now, another concept I just want to talk about really briefly is the idea of a normal probability plot, which is, they're telling you this right here. They have the normal quartile. Okay, I'm just going to tell you this is a normal probability plot. And you see all these points, and let's just cut to the chase. Because these points are approximately linear, whatever this raw data was is approximately normal. And please remember, since it's approximately normal, that means that we can use our Z-score chart. That's the whole rationale behind it. Okay, so take a minute, jot things down, or just listen to me, whichever works for you. So let's look at this first one. He earns a score of 33. We want to calculate and interpret his percentile. Okay, so if he earns a 33, here what we need to do is look at this data right here, and we just find that 17 divided by the total number of 33 is going to give you approximately 78%. We can also look at it this way and go over, but the problem with that is that we can't truly see the exact value. So, and given that he's at the 78th percentile, we're saying that that was his score at that was his percentile given a score of 33. Okay, I want to jump. You can look at this right here. Heather's going to be the exact same thing. So Heather earned 12. So 12 is about here. So you go from here up to 12, then go over. Now looking at the math, the bottom line is you see her score is 12. But I like looking at the Ogive. But here, 3 out of the 23, because that's how many students, gives you 17%. So approximately 17% of the students are at or below 12, because she did better than 12%, and then of course 88% did better than her. Okay, problem 3 here, using the cumulative frequency, using the Ogive, given the percentage. Okay, so we need to find a score of 38, and as we find a score of 38, this is about here, and then we're going to slide over so we can see that this person's at the 80th percentile. And yeah, that's it for that particular type of problem. We are not going to have a problem to convert from a Ogive to a histogram on this test, so it doesn't occur that often, so I'm not going to worry about it. If it does, in the future, we'll revisit. So now I want to take a minute to look down at the list and then see what else I need to cover. Okay, so when to use it? You use this when you're given a percent. Okay, use that when you want to find the percent. Okay, and remember, normal PDF, never, ever, 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 ever. Okay, next, how do I use it? I'm going to show it on the 83. Okay, so remember, you're going to go to second, VARs, and then you see normal CDF. So I think that and the question might be, how do you enter it? Okay, so I've talked about this before. Normal CDF, you've got your left bound, you've got your right bound, you've got your mean, and then you've got your standard deviation. Okay, please remember the following. In your calculator, when you're looking for something that's less than, you're going to enter the negative infinity, which is some extremely large negative numbers, or -1, punch it for a few seconds. Then your right bound, which your right bound is the value right here. So that's your right bound. And then, of course, you put in your mean and your standard deviation. Okay, next, when I am looking for a value that is greater than, you're going to put in that bound, which is right here. because that's the first bound, and then notice your positive infinity, because that's what's going on in here. And then, of course, you need your mean and your standard deviation. And then when you're lucky enough to have something like this, you just put in your left bound, your right bound, and then, of course, your mean and your standard deviation. Okay, next. Can you include the 68, 95, 99.7 rule when it doesn't fall directly on the standard deviation? Yes. When it doesn't, you use your Z-chart. So you use your Z-score chart, or forget that, you use your normal CDF. Okay? I need to look back and go look and see what that's about, so I'll talk about it in a minute. Okay, what does a Z-score mean? A Z-score is when you standardize the data, because the Z-score, if you look at your Z-score table, it goes between a -3 and a positive, -3.4, positive 3.4. Honestly, it goes on forever and ever, but the thing is that when it gets lower than a -3.4 and higher than a positive 3.4, it's so small that it doesn't matter, meaning it's like 0.00 to a negative something power. So that's why we say in general, based on your chart, is between a positive and negative 3.4. A Z-score is a way to standardize information to figure out what the average distance away from the mean once standardized. So again, how to find the average distance away from the mean once standardized. How do I set up probability? Just refer back to the example that I did earlier. That's how I set it up. Cumulative relative frequency, I've talked about that. And yes, the density curve, well, the rectangular one I'm going to do in a minute. Okay, I'm not going to talk about how to change an ogive to a histogram because it's not relative. And the reality is, this thing is already 17 minutes, so I need to move faster. Okay, so please take a moment and write this down as we look at number 7. Okay, so also don't forget, I just added this. Put your markings here. Now, let's answer this question. Okay, so we have a TV show. When it's supposed to end, the precise time it's supposed to end is here at the 0. Think of it as if it has been standardized. So that's the mean value. So we're talking about within 5 seconds, because all of these represent seconds. Well, 5 seconds is about here. 5 seconds is about there. Okay, so at some point it stopped, and I really don't know when it is, so I'm going to have to do this again. Oh, my goodness. Okay, so I was saying that they want me to go 5 seconds within the hour. So within the hour means plus or minus 5. If they say away from it, it's still plus or minus. So now I have to find the distance of the horizontal. So the distance of the horizontal is taking me from a -20 to 0 is a distance of 20. From 0 to 50 is a distance of 50. So the distance between here is 70. So now I know the area under the curve is always 1, so that means that's 1 over 70. Because remember, 70 times some number gives me a 1, multiplied by the reciprocal. So if the distance from here to here, so this is a -5, and that is a +5. If the distance from here to here is 10, now I'm just going to go 10 times the 1/7 as I use an area model, or 170 rather, and that gives me the area that I'm about to highlight right now to be 1 over 7. So I've done 2 things. I have shaded the appropriate area, and I have answered the question. I didn't say it, so here, whatever 1 over 7 is, do the math and figure out what the percent is. And this is your answer. And again, do the math, write it into an appropriate sentence. Now, the computer just told me that I'm about to run out of storage. So for that reason, I need to just jump to the last problem. Okay, so I want to talk about this Frappy, specifically problem part C, because you will see that tomorrow. So go ahead and read it. Now, even though you have access to the answers, you may not understand what they're saying. So let me just show you an easy way of doing this. I want to remind you that why you add and why you multiply. We talked about this in class or during tutoring a couple of times, so this is going to be redundant for a couple of you for a minute. Okay, so if I just take the numbers 4, 5, 6, 7, 8, and I ask you to find the mean of this is equal to 6. Now, if I ask you to find the standard deviation, honestly, I don't know exactly what it is because it's not that serious. But I do know, look at the distance between these numbers. It's small. They're consecutive. So it's going to have a small standard deviation. Okay, when I say consecutive, they go from 5 to 6, to 6 to 7, to 7 to 8. Now, what if I add 10 to all of them? So when I add 10, I got a 14, a 15, a 16, a 17, and an 18. Your mean is still going to be that middle value. Okay, and that standard deviation, look at the numbers right here. Oh man, it's not even showing well. I'm sorry. So as I was saying, your mean is still going to be in that middle value. Your standard deviation, well, when you calculate it, it's going to be the same. And even if you don't calculate it, look at the distance between the numbers 15 and 16, 16 and 17, 17 and 18. Again, they are consecutive. So that proves to you right there, using these nice cute numbers, that whatever the standard deviation for this is going to be the exact same as this, because look at the distance between the numbers. And I realize 100% that standard deviation does not mean the distance between the numbers, but it does tell you the average distance away from the mean. And whatever it is here, because of the consecutiveness of these numbers, yes, I made up another word, it's going to work here also. Now, what happens if you multiply 10? I'm talking about the original numbers that I have here that I'm about to highlight. Okay, so now this is 40, 50, 60, 70, 80. The middle number, as always, is the mean. And we can see how that differ from the original values. It's 10 times the original values by a constant or a multiple of this. But let's look at the standard deviations. These numbers are no longer consecutive. These numbers are now what you call decadent. Okay, so going from 50 to 60, that's more than one number. Going from 60 to 70, that's more than one. So when I multiplied it, the standard deviation got bigger. With that being said, now let's look at question number C, or letter C. When you are asked, or when you, so write down what you mean in your standard deviation. Now, at some point, we're going to have to focus on this equation, because you're going to be given an equation tomorrow, and you're going to need to recognize what happened. But the difference is, on this one, you have to find the variables and find the equation. For the one on the test, you are given the equation, and you had to figure out how it changed. Now, we established a couple of minutes ago that the idea is that when I add a constant, which is what they did there, add a A, and multiply by a constant, which is what they did on that part right there, it affects my mean big time. Two things can happen to my mean. But when it comes to the standard deviation, not so much. The standard deviation is only affected by a multiple. The standard deviation is only affected by a multiple. So 4 times some number is going to give us 10. Okay? I may as well put an X in there and look a little algebraic. So you can see X is going to be 2.5. So that tells you right there 2.5 is the multiplier. Okay, now next, I'm going to take this and plug it into that equation. So here, they said that the new score, which is 80, is going to equal the shift, which I don't know, plus B, which I found, which is the multiplier, times the old score, which, where is it? 22. For those of you who are saying, well, Miss Yarbrough, would I use the mean or the standard deviation? You can't use the standard deviation twice, guys. Remember your algebra. Okay, so yeah, you're just going to take it and you plug it in, and eventually you're going to find A to equal, where is the answer? A is going to equal 25. Okay, so there it is. Now, unfortunately, well, let me stop for a second. So one of the requests that was texted to me was 2.12, part C, asking how do I find the interquartile range. Now I know you have access to the answers and you can look at it this way, and the reality is, oh, this is exactly what I would do, so never mind. Here's you use the inverse norm for the 25th percent, and then you use inverse norm for the 75th percent, and then you are going to subtract the two, and that would get you your interquartile range. Goody, goody, goody. They did it like me. One less thing I had to write down. Okay, so taking one for the team, guys, because what time is it? Oh my gosh, it's almost 6 o'clock. I don't have time to do any more notes. So if you have any last minute questions, come and see me tomorrow morning at 7:30. I will see you later. Happy studying. Bye-bye.